John. Good morning, everyone. It's really great to be here and be part of this community focused on productivity of developers. My name is Ali. I've been at Uber for the past 6.5 years. And when I joined Uber, there was no team really focused on developers. And I was kind of given a blank slate of go after this problem. And over the past 6.5 years, we've built up an organization called Developer Platform with about 200 engineers, some of whom are here and are going to speak today and tomorrow, where we're focused purely on the productivity and the happiness of our developers. So today I'm going to talk a little bit about how we go about productivity engineering and focusing on our developers at Uber, what we've built and how we approach things. And when you talk about developer productivity and everything related to it, it's really important to put things in the context of the business, because after all, that's what we do. We're supporting the business and we're helping the business grow and become profitable. So just to set the context, I want to talk a little bit about Uber and what the business is about. We are all about transporting things in the real world, helping people go anywhere they want or to get anything delivered to them that they need. And our mission is to reimagine the way the world moves for the better. So we're all about transportation in the real world. And if you look at our business, there's 3 major lines of business. There's the mobility business, which is all about moving people around. There is delivery, which is all about delivering food and increasingly other products that you need to you in real time. And then there's a growing but smaller business of freight. If you look at how we operate in more than 70 countries across the world and 10,000 cities. We serve about more than 25 million trips a day, serving 137 million active customers every month. And if you look at the business, how it's grown, the data at the bottom, the chart goes all the way back to the end of 2016, around the time when I joined Uber. And you can see that our gross bookings have been growing steadily or up until the pandemic there. You can see the impact of the pandemic where we had 2 quarters of decline and then accelerating growth after that as our delivery business really kicked in. And we've been continuing to grow now about 18% year over year in our gross bookings. So pretty healthy business, growing very healthily, serving customers across the entire world. Now, supporting that business is our technology platform. We have about 15 mobile apps at this point that run on 5,000 microservices that run on an infrastructure that is spread across 2 regions on the West Coast and the East Coast. Each of those regions consists of a combination of on-prem, our own data centers, as well as now Google and Oracle Cloud. So we are very much hybrid and running across a combination of both our own data centers and our own hardware and our own infrastructure, as well as the cloud. And we run on approximately 1.8 million CPU cores, and you can see all the other stats there in terms of the volume of storage and data. And we have about 2 billion user sessions a month and 2 trillion mobile events that we consume from our mobile apps every month as well. Now, how do we support development for that technology? We currently are spread across 10 engineering sites. We have over 4,500 engineers at this point. We've been growing our workforce steadily over the past couple of years. And those engineers develop across 6 major platforms that we support in the Developer Platform organization. We have mobile with Swift and Java and Kotlin on iOS and Android. We use Python for data and ML. On backend, we do development primarily in Go, but there's also plenty of Java in our backend services as well. And then for front-end web development, we use JavaScript running on Node. Now, those developers across these platforms commit about 65,000 code commits every month. And we have over 100,000 production deployments of services every month as well. And that's been increasing rather rapidly over the past year as we've rolled out safe deployment practices that are automated and programs to make sure that we keep our services up to date and fresh in production. And as we move towards more and more continuous deployment. So previously we had continuous delivery. On every commit, you had an artifact that you could go deploy, but that was triggered manually. But now we've moved increasingly to continuous deployment, where every commit results in a deployment into production. And some commits get multiplied. If you're committing to the platform, at the platform level, some library that's critical, many services might get rebuilt and deployed, which is why you see that ratio being more than 1. And then our code is stored in monorepos. So we have one monorepo per platform. So all services are in one repo. All Go services are in one repo. All Java services are in a separate repo, and so on. And we use about 7 different major programming languages that we've standardized. Now, given our business, there's a lot of challenges that impact us when it comes to developers and the tooling and the processes that we have to support development. First, we're always juggling 3 major forces. One is velocity. How fast, how quickly can we ship features? The quality of our apps and the reliability of our services and the cost efficiency of those services as well. So typically, we're always trading one for the other because it's really hard to be optimizing all 3 at the same time. And which one we're focused on really depends on where the business is. So initially, we were very much about velocity. How can we commit code, get things out there, and run experiments quickly, launch features, launch new apps, and so on. As we grew the business, it became important for us to also worry about quality, making sure that the quality app is very high and the service is really reliable and there for our consumers. And that became more important as we grew and we had competition. And now the phase that we're in is cost efficiency, right? We want to become more and more profitable. So now the cost of our services in production and the cost of developing code become really, really important. So we're very much now focused on cost efficiency. And then since we're running globally across the entire world, our business is highly regulated. Every city that we operate in has a different set of rules and regulations that we have to comply with. So we're also balancing compliance, privacy of the data of our customers, security of our systems, and then safety is very important as well. Since we're moving people in the real world, safety and making sure that we're not shipping bugs that cause safety issues become super important. And all of these factors impact us in terms of our development processes and our tooling. So what's our strategy as a developer platform team? How do we go about building a strategy of tooling and process? First two aspects of our strategy involve making sure that the tools that we provide for our developers are fast and they're the latest and greatest tools out there. The other part of it is making sure we have really good frameworks for developing in every single one of those platforms. So frameworks for writing services, frameworks for writing our apps, and frameworks for writing our web apps as well. And the combination of these two give you velocity, allow you to ship features very quickly, right? Do more with less code and be able to get it out there quickly and reliably. But as you go faster and faster and commit more code and ship more features, reliability becomes an issue, right? The primary cause of any kind of incident and outage or any kind of bugs is always change that is being introduced. So it's important as you increase velocity to also introduce safety nets in the form of testing, static and dynamic analysis, code review processes, as well as safe rollouts so that you can have safety nets around services that as they're being rolled out, as well as the apps as well, so that you do progressive rollouts and limit the blast radius of changes so that you can have those safety nets as you move faster. And then as a centralized organization, the key thing that allows us to operate efficiently as a developer platform team is standardization. When I first started at Uber, basically every team had carte blanche to do things however they needed it to in order to ship code. But that became super hard for us to support centrally as a platform team. And it became really hard for us to put in those safety nets. And it became almost impossible for us to provide really awesome tooling and framework support. So it was an important part of our strategy has been standardization, making sure that everybody is using the same tools, the same frameworks, the same process. And that gives us efficiency as a centralized platform team. Now, the other thing that standardization gives us that is a really important part of our strategy is measurement. So the next part of our strategy is measuring what matters, making sure that we can measure how we're doing, finding opportunities for improvement, and then feeding that back and iterating constantly so that we're always improving and knowing exactly how we're doing in terms of productivity and quality. And recently, in the past 6 months, we've added a new aspect to our strategy, which is AI, which I'll talk a little bit about today. But tomorrow, you're going to hear from Gautam and Serdar from the team as well of what we're doing around AI. So for standardization, I'm going to talk about the bottom 3 things here: standardization, measurement, and AI. I'm going to touch a little bit about each one of those today. So standardization, we've moved everybody onto a per platform monorepo that we eventually, in the long term, plan to move to one single global monorepo for the entire company, as well as frameworks, right? So one framework per platform. And then that has also allowed us to standardize the set of tools that developers use for writing code, for reviewing code and committing code, and everything else. So that's how we've standardized things there. And the workflow also goes through a standardized workflow. So regardless of whether you're writing backend code, web code, mobile code, data, you by and large go through the same workflow for designing, whether it's product requirements or engineering design, local development in terms of your edit, build, run loop, which we completely manage for you, CI, code review, merge queues, and continuous delivery. The process, by and large, looks very similar across all the different platforms that we have. They diverge only during the release phase of how we release mobile apps or how we deploy services into production. Now, one thing that this gives us now is the ability to measure the process and optimize it. And in terms of optimization, we focus on 3 things. First, reducing latency, making sure that all the tools in this flow are as fast and reliable as possible, and that there's as much automation as possible. So skipping steps, automating steps as much as possible to get developers out of the loop. Impact of failures are really important. So if you look at this process diagram, you see these red backward branches, right? These are error paths that then set you back to the beginning again, right? So one of the things that we focus a lot on is reducing the impact of those failures by shifting things left, meaning trying to find errors sooner rather than later, where they're much cheaper to fix and their impact on the customer is not there. Increasing the signal-to-noise ratio, so making sure that we have as few possible false failures as possible. So false positives are a bad thing throughout the entire workflow. That's another thing that we really focus on. And then if you do have failures, improving debugging, right? Debugging is a big, big challenge for us, as I'll talk a little bit about later. And then finally, improving the productivity of our developers, which means giving them as much uninterrupted focus time as possible and giving our teams autonomy to do the work that they need to. There's a lot of measurements that we do at Uber to understand how we're doing. But at the end of the day, the one measure that really matters the most for us is developer satisfaction and developer sentiment. And for that, we do an NPS survey. And here you can see the scores that we've had over time, starting from back in April, which is approximately the time I joined in 2017, all the way to the current NPS survey that we're running. And we've been steadily improving sentiment over time. So our strategy has kind of been working. And you can see how bad things were when I joined. -50 NPS is pretty poor. And we were really excited when in the past year, we finally got to a positive NPS. So this is the primary thing that we really measure, is how satisfied are our developers. And if you look at the feedback that we get from our developers, they've kind of changed over time. But now, if you look at the latest year data, they complain about two major things. One is things related to quality. Man, there's two things there. The difficulty of testing. You're deploying a service, you have 5,000 other services that you're integrating with. How do you have confidence that that deploy is not going to break anything and cause an incident? So testing is a big theme in the feedback that we get currently. And then debugging, the failures that you get throughout the process, whether it's a build failure, a test failure, either locally or in CI, a test failure in staging, or some failure in production, debugging is difficult. And then the other part that's always a constant in the feedback that we get is tooling speed and reliability. Right? Developers want fast tools. It can never be fast enough. And IDEs really matter. And so this kind of sets up for the next part of my talk, which is about AI. And our AI strategy focuses on these things. Starting with IDEs, we've rolled out CoPilot across the company. And we did this about a month and a half ago. And the early results that we're getting is that we're seeing about a 30% acceptance rate in the suggestions that CoPilot is giving. And I'm hearing also that this might be even an optimistic number. So the real rates are probably lower than this. And with 1.4 lines of code per accepted suggestion. So what we're seeing is that this seems to be effective for small, simple boilerplate code. But oftentimes, it also gives you bad suggestions, which is why you see the acceptance rate being really low. Overall, though, developers seem to like it. So what we're doing next is building our own code assistant, right? And the thing about CoPilot is that it uses open source code. What we want is something more tailored to our code base. So we're building our own fine-tuned large language models and experimenting with IDE plugins to see if we can do better than CoPilot by giving it an experience that's more tailored to our code base. The other thing that we've done, which is something that I would recommend, is we ran a hack day, a hackathon, a 2-day hackathon across the entire engineering team. And we got 7,000 participants focused on using AI. And from this, we got about 100 project demos, 100 3-minute videos of demos of stuff that they built during the hackathon. So it was very, very successful. It was great at getting our engineers to play with this technology and learn it and look at some applications and really accelerate the learnings across engineering for how to use AI. And we generally saw 3 categories of projects: improvements to the product experience, improvements in tooling for developers themselves, which was the largest category of things, and improvements in our business operation. So from this, the developer productivity aspect of it, which is the thing that's most interesting here, the one thing that we got away from this that was really, really cool was automated debugging, using AI to automate debugging and automate fixes in our code. I want to just give you this example here first to set up some motivation, which is this is an example of an error that was shipped in a Java service, and it was an error that a static analyzer flagged, but then it was ignored by the developer. And then this made it into production, and it caused an incident that cost us about $35 of over giving money back to users that we shouldn't have, and that was a real cost to the business. And it was something that was flagged by a Java linter that was then suppressed by the developer just so that they can get their code in, right? And we see about 7,000 of these errors every week flagged by our linter. And fixing them is about 15 minutes per developer, right? So one of the things that we were able to do in our hackathon is to build a system that can take the code and those errors, those linter errors, and then generate automated fixes for those errors. And so what we're doing with this is we're building a system right now that can automatically just look at the code base, generate pull requests with fixes, send them to developers who then accept and land them. Over time, we want to do this at PR creation time so that in CI we do this. And then ultimately, we want to shift it all the way to the left and do it in the IDE as you're writing code, right? So as you're seeing your code, have suggested fixes for code around where you're editing or even in the code that you are editing that are fixes to improve the code based on static analyses that we run or even dynamic analyses such as data races and memory leaks. The other exciting thing that that came out is this system that we call drag and crawl. And what this system does is it builds on top of this automated end-to-end mobile testing infrastructure that we have, where you can write scripts to do end-to-end app testing. And what we did is we've built up an AI system, not using large language models actually, just plain old ML techniques, that can go in and then just learn how to make it through the apps and make it through the important flows through our app and test them. And so in this example, what you're seeing is a rider app and a driver app and a successful ride happening between those two apps, all automatically using AI. And what's even more interesting about this is that you train it in one language, and then since large language models know how to translate, using an LLM, we can then also do internationalization for free. So whether it's Spanish or French. And on top of that, we can do it for the different cities because each city has a slightly different interface because, again, we operate in highly regulated environments. So the app itself with feature flagging operates a little bit differently in different locales and has slightly different flows. The AI can actually make it through those flows compared to the system we have today, which is we write scripts for end-to-end testing and it's very brittle because slight modifications to the app flow, a pop-up that comes from Google that's saying you have to now re-authenticate, creates a lot of flakiness in the tests. But using AI, we can get through these tests with much higher reliability. So that kind of brings me to the end of my talk. Standardization is really, really important. That's been one of the keys to our success of having a platform team at Uber. With standardization, you not only get efficiency, but the ability to really measure what matters. And that's really important, having both quantitative measures as well as qualitative measures. So not only things like build time, error rates, and so on, but also how do developers really feel about their tooling and what are the pain points that they're feeling. And this really helps us to drive continuous improvement in the experience of our developers. And then AI is really exciting for us. I think AI really unlocks new opportunities for us in developer productivity. And you'll hear a little bit more about that as well in Gautam and Serdar's talk. So with that, thank you very much for your attention.